folks, welcome to free response number 4. So here we're going to look at geometric and arithmetic sequences and series, and then the binomial theorem. And in A, you can see I've got a geometric sequence. So when you have geometric sequences, you're looking for R, the ratio. And a lot of times A1's a pretty common term they'll have you find, or it's just really important to find for whatever question they're asking you. When we get to the arithmetic side of things, we're not looking so much for R, but a D, right? A difference between the terms, whether that difference is positive or negative. So geometric sequences and series deal with the R's, and A1 is pretty important. Arithmetic sequences and series deal with the D's. And still, A sub 1 is pretty important. That comes up pretty often in those formulas. So this is saying find R, find that common ratio in A sub 1 for a geometric. This is key. Once we know it's geometric, we do know there's an R and well, there's always an A1, but there's a ratio involved. They tell us A sub 3 is 50 and A sub 7 is this Uggo fraction of 25 over 648. And keep in mind, if I wanted to go from A sub 3 and get to A sub 7, right, I would multiply that ratio. That would get me to R. That would get me to A sub 4. If I did another R, that's A sub 5, A sub 6, A sub 7, right? So if I want to go from term to term, I keep multiplying by R. So essentially what I'm trying to say is A sub 7 is A sub 3 times R to the 4th, okay? And then what happens is with this equation, I know what A sub 7 is equal to. I know what A sub 3 is equal to. Right? I should point here, A sub 7, A sub 3, excuse me. And then I can solve that equation for R. So I know 25 out of 648 is equal to 50 R to the 4th. So if I divide both sides by 50, let me go ahead and do this, right? And I'm going to write my variable on the left side. R to the 4th is 25 over 648. Dividing by 50 is like multiplying by 1 over 50. And I'm specifically going to write it that way for this particular problem just because 25 and 50 cancel so nicely. And then I'm going to move over to my calculator and I'm going to say, hey, what is 648 times 2? Let's see what that denominator is. It's 1296. So I know R to the 4th is 1 over 1296. And depending on what works better for your brain, and these next two things are both totally valid, if you have R to the 4th, right, and you want to get R by itself, some folks are going to say, you know what, I want to take the 4th root of both sides. So I'm going to see this notation, right? The 4th root of R to the 4th would be the 4th root of 1 over 1296. Totally valid, right? Some people are going to phrase it another way. They're going to say, well, if I have R to the 4th equaling 1 over 1296, I'm going to raise both sides to the 1/4 power, right? Because I would multiply exponents here. 4 times a 4th is 1, right? And so those would cancel out. Again, these are the same type of situation, right? These essentially we're solving for R. One's just using the radical form, one's using the rational exponent form. So whatever works best for your brain, go for it. So I'm going to go ahead and enter this into my calculator. So let me do 1 over 1296, and I'm going to raise that to the 1/4 power. And I'm going to get 1/6, right, when I turn that into a fraction. So my ratio is 1 over 6. And that's the first part of this question. So I'll write that I found my R value. And if I had enough time on an exam, I would double check this. So if I start with 50 and I multiplied R, I should get to 25 over 648. Let's just see. If I did 50 times 1/6, right? That's 1 R's. I got 2. Oops, shoot. Let me clear this out. Not clear it. Let me redo this. Okay. Times 1/6. There's the second one. Third one. Fourth one. Now let's see if I made that a fraction. Sure enough, that is 25 over 648. So I'm feeling pretty good about finding R. Okay. But I still need to answer the question asked of me. I need to find A sub 1. And you could use either A sub 3 to do this or A sub 7. I'm going to opt to use A sub 3 just because 50 is a nicer number to work with than 25 out of 648. But what I would do, I would say, well, A sub 3 is my starting point, A sub 1 times R squared, right? Because if I multiply A sub 1 by R, I'm going to get to A sub 2, multiply by R again, A sub 3. And the thing is, I know A sub 3, and now I know R, so I can solve this for a sub 1. If you wanted to do it the other way, and I'm personally not going to do it this way, but you also could say a sub 7 was a sub 1 times r to the 6th. That almost looks like a 9. Hold on, let me change my a's. They're starting to look like 9s. So a sub 7 equals a sub 1 times r to the 6th. And you could plug in 25 out of 6, 48 here, 1/6 here. Again, I'm just going to opt to use this because the numbers are a little nicer. So I'll have 50 equaling a sub 1 times 1/6 squared. All right, 1/6 squared is 36. So I'm going to have 50 equaling a sub 1 times 1 over 36. I'm going to multiply 36 to both sides to knock out those fractions. And I'm going to get a sub 1 is going to be whatever 36 times 50 leaves me with. So let's just check this. 36 times 50, 1800. There's my a sub 1 value. And again, if I had enough time on an exam, I would check this. If I took a sub 1 and I multiplied it by 1/6 and then 1/6 again, I should get to 50. So let's see, if I take 1800 and I multiply it by 1/6, that's 300. There's a sub 2. Let me multiply it by 1/6 again, and sure enough, I get 50. So I'm that much more confident in my answer, okay? All right, so let's move on to part B. So part B changes this up in that we're looking at arithmetic sequence now. So it's very common in arithmetic sequences that I'm going to look for a sub 1 and D this time. So not a sub 1 and R, but a sub 1 and D. And then they want us to get S sub 10. That stands for a partial sum. What I really want to do, S sub 10, and we're going to use a formula for this, but if I didn't have a formula, S sub 10 is a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub 10. I mean, I know what a sub 3 is, but I don't know what a 1, 2, 4, 5, 6, 7, 8, 9, 10 are. But I can find them, and I'm not even going to use this like, I don't know, longhand for a sub 10. I'm going to use a different formula. There's lots of formulas. I would recommend you have them on your cheat sheet. All right, so let's take a look here. If I think about a sub 3 to a sub 12, right? 3 to 12 on the index, right? I need to add 9 D's to get from a sub 3 to a sub 12. So what I'm trying to say is a sub 12 would be my starting point of a sub 3 plus 9 differences, right? Because there are 9 terms between them, so 9 times that difference of D. So let's go ahead and solve for D. When I do that, I have 32 equaling 5 plus 9D. I'm going to subtract 5 from both sides. So I'm going to write my variable on the left. 9D is going to equal 27 because 32 minus 5 is 27. And then when I divide by 9, I'm going to get my difference is 3. Okay, great. Another very common thing, or a very fun thing to get, maybe not fun, but popular thing to get is a sub 1. So now that we have D, let's go find a sub 1. And I could use A3 or A12 to find it, but I'm going to use A3 because the numbers are smaller. This should be A1 plus 2 differences. All right, so we would know 5 is equal to A1 plus 2 times 3. So 5 would be a sub 1 plus 6. When I subtract 6 from both sides, right, and I'm just going to put this over here, I know a sub 1 is going to be negative 1. So those are going to come in pretty handy, because I'm going to go ahead and use my partial sum formula for an arithmetic sequence. All right, and so that partial sum formula, right, S sub n would equal n over 2 times 2a sub 1 plus n minus 1d, right? There's a couple formulas. I'm going to opt to use this one, keeping in mind I want S sub 10. I know my starting point, and I know my difference, so this is a great formula to use. So I'm going to put the 10 here. I'm going to put the 10 here. Any n is going to get replaced with 10. And I'm going to put the 10 here. All right. I know a sub 1, that was negative 1. So let me go ahead and put negative 1 in. And I also know d, that was 3. So let me put 3 in. And then it's PEMDAS. So 10 over 2 is 5. Okay. 2 times negative 1 is negative 2. 10 minus 1 is 9. Times 3, okay. So I have this 5 on the outside. I've got negative 2 plus 27. All right, we've got negative 2 plus 27 is 25. 5 times 25 is 125. So that is going to be my partial sum. And if you wanted to really check it, like if you had time on your exam, what you could do is you could take a sub 1, you know, that's -1, add 3 to it. You know, a sub 2 would then be 2, right? You would know add 3 to, again, a sub 3 would be 5. We knew that anyways, right? A sub 4 would be 8, so on and so forth. You can find a1, a2, a3, all the way up to a sub 10, add them together, and they should total 125. Right? The formula is a shortcut. This is the longer way. But again, if you have time on an exam, no harm in checking yourself. Okay, let's go ahead and take a look at this binomial that we're going to expand with the binomial theorem. Now this says go ahead and find the third term. I'm just going to write all of these out so we can see the binomial theorem in play. So I have w minus 2y raised to the 6. So I want you to think w is one of my terms in my binomial expression. -2y is the other one. And I've got this 6th power. So I'm going to do 6 choose 0, right? And then we're going to do the first term to the 6th, the second term to the 0. All right, and then the powers on w are going to decrease, the powers on -2y are going to increase, and these multipliers are going to go 6 choose 0, 6 choose 1, 6 choose 2, so on and so forth. So my second term would be 6 choose 1, all right? Power on w decreases, power on -2y increases. And at any time, these powers should total to 6. All right, next term, 6 choose 2. All right, power on w decreases, power on -2y increases, and those total 6. Great. I'm going to keep on going. We got 6 choose 3. W decreases, -2y increases, they total to 6. I'm going to keep going. All right, we've got, you know what, let me move this over here so I don't run out of room. So then I've got 6 choose 4. All right, we've got w, oops, not to the 4th. Power on w's decrease. Powers on -2y increase. 6 choose 5. Power on w decreases. Power on -2y increases, and then last but not least, 6 choose 6, power on w decreases, and then the power on -2y increases. So if I wanted to expand all of this, that would be this binomial expanded out. But this is asking me for the third term, so let's go first, second, there's my third term, okay? So I'm gonna scooch this up and really just focus on finding that third term, because that's all I really need for this. So let me put some separation. So we're looking at 6 choose 2, w to the 4th, -2y squared. So let's just do 6 choose 2 on our calculators. So I'm going to hit, let me clear this out, 6. We're going to go to our math, okay? And then we're going to go over to PRB. You can hit the right arrow 3 times. I'm just going to go to the left, do option 3. And I need to do 6 choose 2. So it looks like that is the number 15, okay? I have 15. W to the 4th can't really be simplified. -2y squared, well that's -2y times -2y, right? So 15 times -2 times -2, let me think of that as -2 times -2 is +4. +4 times 15 is 60. Then we've got w to the 4th, y times y is y squared. And there is the third term in my binomial expansion. All right, thanks so much everyone. Good luck on that midterm. Bye.